Alright. 6.1. I'll try this again. 6.1 is probably going to be broken up into 4 sections, just so you guys are aware, because it was way too long yesterday, and then some of y'all know what happened. But anyway, 6.1. Alright, so the first little bit is notes. And I do want to let y'all know trigonometry is really about triangles. That's the whole idea with the trig. Geometry is about geometric figures. Trigonometry is pretty much exclusively triangles, which means you already know a lot of this stuff. And that a squared plus b squared equals c squared thing you learned way back when, same thing. Triangles and that pretty much the basis for every single thing we do. So you're taking something you already know, and we're just going to do it in another language. So don't make this too hard. Second page of notes are the 3 major things we're going to do in this class: sine, cosine, and tangent. That is nothing more than a triangle with standard lettering, which is what I laid out on the first page, with an opposite side labeled, an adjacent side labeled, and a hypotenuse labeled. Hypotenuse you should remember. So, starting out with right triangles, the side that is opposite that right triangle is the hypotenuse. That angle and that side have specific names and they do not change. The right angle is labeled as a capital C, the hypotenuse is the little c. The A and the B, swap them around. Who cares? Whatever works best when you're drawing, whichever habit you form, whichever way makes you feel better. One of those little angles is a big A, one of those little angles is a big B. Then the side opposite it is the little a, and the side opposite the big B is the little b. Now, when you do sine, cosine, and tangent, you need to pick one of those angles and stick with it. Normally it's the one that is labeled inside the triangle. Like on my second page, I do the little circle with the line in it. That's just a Greek letter theta. Math people needed way more letters than the regular alphabet gave them. So we've usurped some others. So that theta, I want to do everything based on that particular angle. So the opposite side in this case is the side that is opposite the theta, the little a. The side adjacent, or the side that touches the theta, is the little b. The hypotenuse is still the hypotenuse. The other 3 options we've got, the cosecant, the secant, and the cotangent, are just those 3 turned upside down. So don't memorize those. We need sine, cosine, and tangent. The others are just those upside down. Now the way I usually do this class, in class, would be I would do my little dog and pony show at the beginning, which is not very long, and I usually do problems and talk about the problems as I do them. It is much easier to learn something while you're doing it than it is to learn it and then try to go back and remember what happened. So that's kind of the way I try to do the videos. So flipping through the notes I gave you, I did number 2. If you look in the book, I just recreated that little picture. You've got a funny looking B, that's your beta. I stuck the ABC on there. I can't even remember if they're in there on the book, but I stuck them on there anyway. So the sine of beta is the side opposite it, which is that 0.3, over the hypotenuse, which was 0.5. That's it. Leave it like that. Don't worry about it. This is not arithmetic class. You'll see later there's some other stuff I don't fix. We are doing trigonometry. I'm not going to kill us by bogging us down in details of fractions and square roots and decimals on fractions. I don't care. I'm interested in you knowing that the sine of beta is the opposite side over the hypotenuse, 0.3 over 0.5. Stop. Cosine of beta, the adjacent of the hypotenuse, which the side that touches that little beta is 0.4, because the other side that touches it is the hypotenuse, and it has its own special name, so don't make it too hard. The tangent is opposite over adjacent. We already labeled them. We're just filling them in. 0.3 over 0.4. Then cosecant, turn the sine upside down. Secant, turn the cosine upside down. Cotangent, turn the tangent upside down. I think 4, because I left my little numbers laying out over here. Yeah, 2, 4, 8. Just more examples. 4, here we see the next thing where I'm not going to make you do the arithmetic. I have that the sine is opposite over hypotenuse. The opposite side is 6. The hypotenuse is 13 over 2. So I have 6 over 13 over 2. I don't care if you leave it that way. This is not arithmetic class. It's not even basic algebra. I'm interested in you knowing opposite over hypotenuse, not in doing the rest of the arithmetic. Now, if you're going to go on in math classes, or you're a math major, or a computer science major, or an engineering major, you are probably going to need to know that math teachers after me are not going to like that. They have their own brand OCD, and they do not like stacked fractions. They don't like square roots in the denominators. They don't like decimals and fractions together. It's just their thing. But I don't care. I have other things to worry about. But I did to the side show you what you would do. And you already know how to do this. This is old school stuff that you have to recall. 6 divided by 13 over 2. Write it down the way you just said that. 6 divided by 13 over 2. Then you do the keep, change, flip thing, which is 6 times 2 over 13. Then you multiply straight across the top and straight across the bottom and reduce it. The exact same thing you did in elementary school and middle school and high school. Those rules have not changed. Those methods have not changed. I'm just not going to force you to relive them because we're doing trig. We are not doing arithmetic. Same thing on 8. You've got rationalized fractions to deal with, and then I don't care if you rationalize them or not. On number 8, the sign, opposite over hypotenuse, you get 2 on the square root of 2 over 3. But when you turn that upside down, now you've got 3 over 2 on the square root of 2. Most math instructors are going to flip out because they want you to multiply everything by the square root of 2 over 2, reduce all that stuff, and end up with 3 on the square root of 2 over 4. That's probably, if this were an odd one, that's what will be in the back of the book. I don't care. We are not doing arithmetic. We're doing trig. Get your ratios in there, memorize your opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, and go on with life. It is not going to matter. Okay, cosine, we're up to 10. Cosine, oh, okay. I'm going to do 10. Yeah, I'm going to do 10 and then change gears to another video. All right, so on 10. We have the cosine of sigma. That little stepped on 6 is a sigma if you have to take statistics, which is 0.7. Again, remember back to all that stuff you learned in elementary school, middle school. The actual name of that is 7/10. 7 over 10. Cosine is adjacent over hypotenuse, which means if I sketch myself out a little triangle, and I really don't care what it looks like as long as it's got a little right angle in it somewhere, then I label one of those angles as a sigma. Pick one. Put my little square in there from a right angle. The side across from it gets a little HYP for hypotenuse. Wherever I put my little sigma, I go across the triangle and write OPP for opposite. The only side that's left gets my little ADJ for adjacent. Now, I just did at the beginning, cosine is 7 over 10, which is adjacent over hypotenuse. 10 goes above the HYP. 7 goes next to that ADJ. And I can find the rest of that stuff. Because I know a squared plus b squared equals c squared. I've got the hypotenuse and one of the sides. Can work that one out. When I get down to the square root of 51, I'm just going to leave it like that. If you want to put it in the calculator and round it to at least 2 decimal places, that's fine. I'll take it. I'm good with that. But keep 2 decimal places. Any chemistry majors out there, I'm not talking about significant figures. I'm talking about just 2 decimal places. And then now I have the hypotenuse, I have the adjacent, I have the opposite. I just write them out. I usually write mine out like the chart I did on here, sine, cosine, tangent. Then I write opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, just so I'm making sure I get stuff all labeled out. I'll do those 3. Then right next to them, I'll do each one turned upside down. Because that way I don't have to think to do that second column. I can just write them down, flip them upside down, and keep on going. I like to label stuff. I'm a little bit dyslexic. Some of the mistakes you might find that I missed that I didn't do on purpose, you will discover it's mostly because I'm dyslexic. The way I deal with that is to label stuff. Everybody needs to have some sort of coping skill to deal with however you happen to be. I have mine. All right, I think I'm going to stop right here and pick up in just a minute. Thanks.